Welcome everyone. In today's video, I'm going to explain the second project in this course. In our first project, we studied the block IDs and the thread IDs, and we knew also how to print these IDs from our application. This image represents one of the outputs that we studied in the previous video or in project number 1. In today's video, our main purpose is to look into the third level, the warp IDs. From our previous discussions, we knew that each CUDA application consists of some grids. Let's say one grid. This grid consists of some blocks. This blocks contains different warps or mini warps. Each warp consists of 32 threads. Those are the different software levels in the context of the CUDA programming. So first level, second level, third level, let's write these numbers here. 1, 2, 3, 4, right? From our previous discussions in the first video, we knew how to print the thread IDX, and I told you that we have thread IDs in 3 dimensions, X and Y and Z. And what we do in X dimension can be applied in the other dimensions, but until now I'm going to focus only on the X dimension. So also we studied the block IDs. Today we need to study this level, the warp ID. If we do this, then we understand the different levels in the CUDA software or the CUDA applications. Okay, so this is the same code from project number 1 from the previous project, and all we need to do here is to extend this code to print the warp IDs. So starting from this instruction, I am going to add the warp IDs here. But the question here is there a predefined variable for the warp ID values similar to the block IDs and the thread IDs? The answer is no. In the CUDA programming language, there is no a predefined variable that contains the warp ID value. So what we are going to do here, in the previous project, in project number 1, we were able to print the block IDs and the thread IDs using these predefined variables, and that was very easy. Today, it is not also difficult, but let me give you a simple example. In our previous discussions, I told you that each warp consists of 32 threads. Let's assume that we have 128 threads per block in our project, okay? Can you count the number of warps per block in that case? The answer, yes, we can do this easily. All we need to do is to divide 128 over 32. This will give us around 4 warps per block, right? So how we can calculate the warp IDs using this equation? Okay, so let's start here by defining a variable or declaring a variable. Let's say warp ID value, and let's start it with initialize it with 0, and then let's say that this value will be equal to the thread ID that we need over 32. So if you divide the thread ID, so we have 128 threads, so we are going to make around 128 division operations, okay? So if you divide the thread ID of each thread over this value, the result is the warp ID for each thread, okay? So let's print these values and see what we will have. We need to compile our project and see if we have any errors. Our compilation process finished successfully, so we do not have any compilation errors. So let's run our project. As you see here, we have warp IDs like 14. Do you know why we have warp IDs 21, 30? This is too much. We, according to our discussion, we said that we should see 4 warps per block, right? Yes, that's correct. But if you go down, you can see that we are not using 128 threads per block. We are using 1024, right? So let's change this value to 128 and then rerun our application. First of all, I want you to pay attention for the block ID. From the start to the end, the block ID didn't change because in our application, we have only one block. And if you have one block, the ID of this block will be 0. Okay, so the IDs start from 0. Then going to the thread IDs, we should see IDs from 0 to 127. And this can be observed in this column, in the second column. We have 64, but if you go down, you can see 0, 95, and if you check more, you can find the 127. Regarding the block IDs, you can see that it starts here with 2, but if you go down, you can see the warp ID 0, the warp ID 3, and the warp ID 1. So we have only 4 warps, and their IDs start from 0 and end with 3. Okay, if you go down, let's see this part. It starts from 0 for the warp ID 0. If you go to the end of this warp ID, you can see that the thread ID is equal to 31. So now we have one block in our project. We have 4 warps in our project, and each warp consists of 32 threads. So this is the simplest way to calculate the warp IDs. I want to say and mention that there are many other methods to calculate the warp IDs, but I'm not going to explain everything. I'm just giving you a simple example, and you can build upon this example. So one of these methods is using the remainder, and you can consider that this is your task today. You need to search about using the remainder operation or the remainder calculations to calculate the warp IDs. Okay, but let's start here doing something else. Let's change the number of threads per block to 64 instead of 128. In this case, the total the warps per block will be equal to 2 warps, right? But if we put here 2, for example, then the warps per block will not be changed. It will be equal to 2 warps, right? Because we didn't change the number of threads per block. But what happens here, what changes here is the total warps per GPU. In the first case, if we go back here, the total number of threads in our application is 64 because we have one block and this block contains 60 threads. But when we increase this to 2, then the total number of threads is equal to 128, and 128 gives 4 warps, not 2 warps. Okay, so we have 2 warps per block and we have 2 blocks. Let's compile and run to see how the result will look like. We need to close and then run again. Okay, pay attention to the first column. As you see, we have a block ID 1, and below we have a block ID 0. And this is because we have 2 blocks in our application. Regarding the warp IDs, you can see that we have a warp ID 0 and another warp ID 1. And if you go down, you can see another warp ID 0. Why we see the warp ID 0 twice in this application? Because this ID, this warp ID, is dedicated for the first block. So the warp IDs here are calculated per block, not per the entire GPU. Okay, this is why you can see the warp ID 0 twice in this application.